This is 1.2, solving multi-step equations. So here we're going to first do kind of some review on what the order of operations are. So we have PEMDAS, which stands for P for parentheses. So that means the first thing that we do when we're solving something without a variable involved is we solve whatever's inside the parentheses, brackets, or any kind of groupings that we see. So here, I've kind of given some examples. We've got parentheses, brackets. There's also the squiggly brackets you could use. Or another example of when we use parentheses, we actually are using parentheses when we have a big fraction bar and we have an equation on top and an equation on bottom. We actually treat these as if they're inside parentheses. So we solve them first before we actually divide our answers, right? So we would solve whatever this is and then solve whatever this is, and then we would divide the two answers, okay? Then the E stands for exponents, but this also includes roots. So if I'm taking a square root of something as well, so a to the something or a to the b root. So if I'm squaring something or cubing something, and if I'm taking the square root of something, those kind of fall into the same step category. And then next we have multiplication. And this includes multiplication and any kind of sign. So like if we have a negative sign out front of something, we would include that as a part of our multiplication process. And along with multiplication, in the same family, that's why I kind of bracketed them together, is division. They actually belong to the same step, but it's just easy to decide which one we're going to do first. So in general, I try and do multiplication first and then start dividing. But it actually doesn't really matter. You can do either step in either order. They belong to the same family because they're inverse of each other, right? The opposite of multiplication is division. And so here are some examples. You could have A dot B is multiplication, AB, they're in parentheses next to each other, then we know we're going to multiply. If there's a sign out front, then we know we include that. That's all within the multiplication step. Division, there's only really two ways to look at it. Either have the divided by sign, which you'll rarely see this. You'll most likely see it like this, as a fraction. A over B is the same thing as A divided by B. And then finally, our last step, this one's pretty straightforward, but they also belong in the same family. So you usually just solve from left to right, and you just do addition and subtraction as you go down from left to right, right? So they're interchangeable with each other because they're basically the same thing. They're just the inverse of each other, okay? All right, so now that we've looked at PEMDAS, we're going to look at a new order of operations. And so this is the order of operations we consider only when we're trying to solve for a variable. So when a variable gets involved, there's actually a completely different order that we want to go in. And so the new order is what we're going to call it. We're actually going to call it, I'll show you the whole thing so you can see what we're going to call it. We're going to call it the new order for solving for variables. And so that's going to look like this. So the first thing that we look for is we look for any steps of the distributive method. So if we see a number out in front of a parentheses, we're going to distribute that number first. So that's actually going to be our first step we do for all of these types of problems. Then the next thing we're going to do is we're going to combine like terms. So if there's like terms to be combined, we're going to go ahead and put them together, right? And then the third step, you'd think that you would do PEMDAS, but no, actually, you're going to write PEMDAS and then cross it out. You're actually going to do PEMDAS backwards. And so I call it SADMEP, right? Because when you're undoing an equation, so when you're trying to peel back the layers to get to the middle of the equation, get to that variable, you actually have to think of things backwards, right? So you're going to subtract before you would multiply, right? So you're going to subtract something before you would multiply something to move it to the other side. So just like we're undoing things and doing things backwards, we're going to do the order of operations backwards as well. Okay, so let's do an example where I'm kind of just going through all three and doing them one at a time, checking for each of them. I'll put an X next to it if I don't need to do it, and I'll put a check mark if I do need to do it, okay? So here's some examples. Example A is 1.5x plus 15 equals 24. So if I'm looking at this, I'm I would first ask, is there any kind of distributive method? Well, I don't see any parentheses, so I'm going to assume there's no distribution that needs to happen, no distributing. So I'm going to put an X next to that. Don't need to do that step. Then I'm going to ask, are there any like terms? No, there's no like terms. We don't have any X's next to X's. We don't have any constants that need to be added together that are on the same side of the equal sign. So we're mainly looking at the same side of the equal sign. So here I just plot this out and I look. Do I have any like terms? No. And I look at the other side. Any like terms? No. It's just 24 by itself. And so then I go to the next step, which is following SADMEP, which is PEMDAS backwards. So I ask myself first, is there any subtraction that needs to happen? And the answer is yes. To get rid of the 15, I have to subtract. So I'm going to subtract 15 first. When I do that, I get 1.5x by itself on this side, and then I have 9 by itself. And here you can see I'm doing a different step here, so I'll just plot that out so you can see what we got here. So I end up with 9, and then I ask myself, is there any addition? There's no addition that needs to happen, so I'm going to put an X next to the A right here, right? And then I ask myself, is there any division? And I'm going to put a check mark because, yes, I can divide the 1.5. So I'm going to go ahead and do that, dividing both sides by 1.5. However, you'll see that I don't like dividing decimals. So I'm going to move the decimal over to the side. But if I do that on the bottom here, I have to do it to the top, which adds a 0. So now I'm asking the question, not 9 divided by 1.5. I'm actually asking the question, what's 90 divided by 15? And the answer is 6. If you added up 15 6 times, you would get 90. And so the answer here is x equals 6. Okay? So you kind of just go through that method with all the different problems. I'll kind of show another example of a problem here so we can see what it looks like to start to think about combining like terms. So notice we consider like terms only when they're on the same side of the equation. So here I've got like terms with 8x and negative 6x. So I want to put those together first. Well, first I'm going to ask, is there any distribution? Any distributive method that needs to happen? No parentheses, so I put an X on that. There are like terms in 8x and negative 6x. So I put those together and I get 2x minus 25 equals negative 35. And then I just go through and I put a check mark next to anything that needs to happen. So I need to add, right? Opposite of subtraction is adding. So I need to add to both sides. So that's going to be the first thing I do. And then I also need to divide the 2 away eventually. So that's going to be the next thing I do. I don't have the other 3 steps. So let's do that in order. We're going to add first, add 25. Changes my answer to negative 10 on one side. Got 2x left over on the left side. And then I divide by 2. So I end up with x equals negative 5. Okay, so that's all the examples for that. Let's go ahead and we're going to open this up in another video. But I want you to go ahead and try page 14, number 6 through 9 all. So go ahead and try that and we'll come back.